All right, hey guys, this is lesson 3 from chapter 5. So this is the official notes for slope for day 1 here. All right, so we've talked about slope a little bit already. Slope is a measure of the steepness of a line on a graph. So how steep is it? Okay, it's the ratio of rise to run. So when we write it as a fraction, rise is going to go on top and run is going to go on the bottom. Okay, and then rate of change, slope really is a rate of change, so it's the ratio, again a fraction, of two quantities that change. Okay, so we've already talked about these types of slope. I just wanted to add it to your notes just in case you need it. A reminder, so positive slope is going to go up and to the right, negative slope is going to be going down to the right. If it's like the floor, a horizontal line, we have zero slope, and a vertical line is going to have undefined slope. Okay, so the first part says tell whether the slope is positive or negative, and then find the slope. So if I take a look at this line, first of all, the line points upward. And what that means is that the slope is positive. Okay, so next we have to calculate the slope by doing rise over run. All right, so what we're going to do on the graph is we're going to draw ourselves a right triangle either above or below the line. It doesn't really matter what you do. And I'm going to draw the rise here in pink. And that rise ends up being 3. So again, we're going to count the boxes. So I'm going to put a little tick mark here in the middle of the box. 1, 2, 3. And then the run going this way. If I count those boxes, it's 1, 2, 3 as well. So the rise is 3 and the run is 3. Okay, so if I were to simplify this fraction, 3 over 3 does simplify to 1. So this line has a slope of 1. Okay, so this one is going to be a little bit different than we've been doing so far. It says use the slope of negative 2 over 1 and the point 1, negative 1 to graph the line. So first thing we need to do is make sure we have that point plotted on there. So from the point 1, negative 1, oops. So we're going to plot that point 1, negative 1. Okay, and then we're going to use our slope. So the slope here is negative 2 over 1. And again, that's rise over run. So one way we can investigate this is to do it exactly how it tells us, which is negative 2 rise and a positive 1 run. Okay, so from here, what we can do is negative 2 is the rise, so I would go down 2 units, and then the run is positive 1, which is going to be to the right. So I would go right 1 unit, and there is a point on the line. Okay, so we have talked about this in the past, that it doesn't matter where the negative is in the fraction. The negative could be out in front, it could be on top, or it could be on the bottom. So another way we could think about this is to do positive 2 over negative 1. Okay, so if I were to do that instead, which would be starting from the original point, 1, negative 1, the positive 2 for the rise would mean go up 2, and then the negative 1 for the run means to go to the left 1. So either way, you're going to notice that if I do it the way it says, which is rise negative 2 or down 2 and right 1, it's the same as if I were to go up 2 and left 1, because those points are going to land on the line. Sorry, give me a second to get a straight edge here. Okay. Now when you draw your line, draw it as far as you can in the entire coordinate plane and make sure you put arrows on the ends, because that line does go on forever in both directions. Don't just connect the dots that you drew. Okay, so one of the ways that we just did Okay, the first way that I described was we could have moved 2 units down and 1 unit to the right, or the other alternative method was to move 2 units up and then 1 unit to the left. Okay? All right, so this part here, it says, tell whether the graph shows a constant or variable rate of change. So we do need to talk about constant rate of change and variable rate of change. Okay, so the word constant means stays the same. All right, so a constant rate of change is going to just always be portrayed by a line. Okay, so this is an example here, this is an example here, or even like a horizontal line. Okay, variable rates of change happen, the word like variable has the word vary in it. Vary means that it changes. So a few examples of that would be if a graph like started by going up and then coming down, that's a change because it was increasing and then all of a sudden it's decreasing. Or anytime you see a curve on a graph, that is going to be a variable rate of change because it isn't always increasing at the same rate. Like down here, it's increasing slowly and then it starts to speed up. All right, so in this one, the graph is not a line. Basically, we're looking for a line. If it's just a line, it's constant rate of change. If it's not a line, that makes it variable. Okay, because it goes down and up and down and up and down and up. It keeps changing. Okay, this next problem says the graph shows the distance a monarch butterfly travels over time. Tell whether the graph shows a constant or variable rate of change, and then find how fast the butterfly is traveling. Okay, so since we have a line here, that is a constant rate of speed. Okay, so the amount of distance is going to be the rise. And I know that because rise is up and down, and that's distance on the y-axis. And the amount of blank is the run. So the run is going to be this horizontal change, which is time. Okay, so we can find the speed by finding the slope. The speed is a rate of change, and slope is a rate of change. So to find that, we're going to do rise over run. And all we have to do is find 2 points on the line, okay, and find the rise and the run. So rise. Here, if I show my rise from the first point to the next point, you have to be careful. It looks like we're going up 2, but we have to be careful of what the interval is on the y-axis. So notice here, every space is 20 miles. So really, the difference here between 60 and 20 miles is 40 miles. So our rise is 40. Okay, and then on the bottom, we're going to have our run. The run is going to be the horizontal change. Now, if I look along the x-axis, we are counting by ones here. So this one goes over 2. All right, we can always simplify 40 over 2. If I divide that, would be 20 miles per hour. Okay, this one says tell whether the slope is positive or negative and then find the slope. So in this case, it is sloping downward. So we're going to have a negative slope. And now we have to find the slope. Okay, again, I'm going to do rise over run. So in this case, on my graph, I like to go from left to right. You can count up and back if you want to, but just be careful with your negatives and positives. So for me, going left to right, This is going to be my rise right here. Okay, and we are going down. So this is going to be a negative rise. I'm going to count the boxes. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is a -8 for my rise because down is the negative direction. And for my run, I am going to the right 2. Right is a positive direction, so that is 2. If I were to simplify -8/2, that would be a -4 for my slope. Okay, we are going to spend one more day on just the lessons for this, so please let me know if you're stuck. I know this is kind of challenging content.